Hello everyone, welcome back to another video of MRB Pharmacist. So we are here again with the Master Stroke series, and in this Master Stroke series we will be discussing questions from biochemistry, and the topic of today's class will be lipids. So let's have some questions from lipids. Like first question we are having an example of a saturated fatty acid. So a saturated fatty acid among the following will be a palmitic acid, oleic acid, linolenic acid or arachidonic acid. So we are having this palmitic acid, that is a saturated lipid. It's a saturated fatty acid, while oleic acid, linolenic acid and arachidonic acids all are having unsaturation. So they are unsaturated fatty acids, while this palmitic acid is a saturated fatty acid. So yes, A will be the right answer here. A will be the right answer. So in case of unsaturated acids, we are having palmitic acid, oleic acid, palmitolenic acid, next we are having oleic acid, linolenic acid and linoleic acid, arachidonic acid. These all are having basically unsaturations, while these are some saturated, like having only single bonded carbon-carbon system. So they are saturated fatty acids. All right. So before moving to the next question, as you all know that the test series, free of cost test series, that is also running just parallel to this like Master Stroke series. So you can simply join in that and test your preparation. You simply go to GDC classes application, and in the batches section just enter the batch code MRB25, and yes, you are done. You will be forwarded to the free of cost test series that is running in that batch. Okay, the next question we are having, which of the following is an essential fatty acid? So essential fatty acid is that fatty acid that has to be consumed with the food sources. So we are having linoleic acid, linolenic acid, arachidonic acid or all of these. So we have been asked about the essential fatty acid, like essential fatty acid. So yes, these all fatty acids are essential fatty acid. They all came under essential fatty acid categories. So yes, D will be the right answer here. D will be the right answer. Like arachidonic acid, linoleic acid and linolenic acid all are actually essential fatty acid. So yes, all are correct. Like eicosanoids are polyunsaturated fatty acids. They are polyunsaturated fatty acid of what total carbons? So in case of eicosanoids, so eicosanoids are having basically 20 carbon structure. So it's a 20 carbon structure, 30, 25, 15, 20. All right. So D is the correct answer. Like eicosanoids will be having 20 carbon system with unsaturations. So yes, it will be the right answer here. Like arachidonic is 20 carbon containing, while linoleic acid is having 18 and linolenic is also 18 but having 2 double bonds. Okay, so yes, it's correct for them. Next question we are having, richest source of lecithin. So lecithin is richest in meat, egg yolk, fish or milk. So when we talk about lecithin, it's actually the richest source found inside the egg yolk. Okay, so yes, B will be the right answer here. Like egg yolk is rich in lecithin. So chemically lecithin is lecithose, that is egg yolk itself. All right. So next question we are having, name of the reagent used in saponification reaction. So saponification reaction, like also known as soap formation reaction. So the reagent that are used during saponification reactions is ammonia, acetic acid, NaOH, KOH or citric acid. So yes, C will be the right answer here. C is the right answer. Like this NaOH or KOH is basically used for the saponification reaction of a fatty acid. So yes, C will be the right answer here. C will be the right answer here. Like triglycerols, when reacted with NaOH, it is produced by glycerols and the soap, that is salts. Rancidity of fat is due to, so the rancidity of fat is due to oxidation, saponification, hydrolysis or neutralization. So yes, this rancidity, or you can say the degradation of particular fats or oils is due to oxidation. So yes, this oxidation will be the right answer here. All right. In the next question we are having, iodine number is the measurement of fat. Like iodine is what measurement? Iodine number gives what type of measurement? Like molecular weight, unsaturation, free fatty acid chains or none of these. So basically this iodine number basically provides you the total unsaturation in that particular fatty acid chain. So yes, the unsaturation is the measured, or the total unsaturation basically is measured inside a fatty acid chain via this iodine number. So yes, B will be the right answer here. B will be the right answer here. Next question we are having, high content of triglycerides is present in. So the triglycerides are present in high content in LDL, HDL, VLDL or chylomicrons. So these are chylomicrons. These chylomicrons basically you can say that they actually carry this fats and oils, or you can say that this lipid from intestine to the peripheral muscles, peripheral tissues. So yes, D will be the right answer. They are actually having rich in triglycerides. So yes, D will be the right answer here. D will be the right answer here. And this HDL is also known as good cholesterol. The constituent of cholesterol termed as bad cholesterol is, so the bad cholesterol is termed as HDL, LDL, VLDL or triglycerides. So this LDL, or you can say that low density lipid, this is actually bad cholesterol. They are termed as bad cholesterol, and this VLDL is responsible for the production of this LDL, and this HDL is basically known as good cholesterol. This HDL is basically good cholesterol. So LDL is the other name for bad cholesterol. So yes, B will be the right answer here. B will be the right answer here. Like low density lipoprotein may be regarded as lethally dangerous lipoprotein, that is also known as bad cholesterol. Small dense LDL is considered to be the most dangerous fraction of LDL associated with the congenital heart disease. They are formed from VLDL in the blood circulation. They transport cholesterol from liver to the other tissue organs. Next question we are having, which of the following is not a phospholipid? Which is not a phospholipid? Sphingomyelin, lysolecithin, cardiolipin or galactosylceramide. So not a phospholipid. When we talk about lipids, yes, sphingomyelin is a phospholipid. Lysolecithin is falls under the category of phospholipids. Cardiolipin is also a category of phospholipid, but yes, this galactosylceramide, this is not a lipid derivative, not a phospholipid derivative. So yes, D is the right answer. Like this galactosylceramide is not a phospholipid derivative. Here is the classification of lipids, like simple lipids, compound lipids and derived lipids. So basically simple lipids are the ester of fatty acids. So true fat, wax, they are under the simple lipids. Now compound lipids, the major category. So this compound lipids is having esters of fatty acid and other groups. So phospholipid, glycolipid, sphingolipid and lipoproteins. So they are all classified. How they are all classified? And the derived lipids are having hydrocarbon ring and long hydrocarbon chains. So yes, these are some classifications about the lipids. Alright, so for the MRB Pharmacist, GDC classes is also having a specifically designed content for the syllabus of MRB Pharmacist. So yes, the theory and the objective book that you can opt for your preparation, as well as we are also having some of the premium class test series that you can opt for your complete booster of your particular ranks in this examinations. And we are also conducting the crash course for this preparation of MRB Pharmacist, so you can simply go and check out all these in details inside that particular classic GDC classes application. Now sterols belong to the class of, so sterols, now you can see that this is actually a made from two objects like steroids and alls. So alls means that they are OH derivatives like alcohol derived, and steroids. Steroids are basically phenanthrene when joined with phenanthrene group joined with a, or you can say that fused with a particular cyclopentane ring. So cyclopentane ring when fused with phenanthrene ring, it actually constitutes the steroids. It actually constitutes the steroids. Now alls is representing that there is also a presence of there is also some presence of OH, that is hydroxyl groups. So yes, they are none other than lipids. They are actually lipids, no waxes, not carbohydrates and not proteins. So yes, A is the right answer here. Like sterols belong to the classes of, sterols belong to the class of lipids. A will be the right answer here. A will be the right answer here. Like 3-benzene ring when non-linearly fused, they are actually termed as phenanthrene derivatives, and here we are having a cyclopentane derivative, and this is our steroid nucleus. This is our steroid nucleus, and when this steroid nucleus is fused with a 1, 2, 3, 4, 5, 6 member carbon ring with 2 methyl substitutions, this is actually known as cholesterol. So basically cholesterol is having 27 carbons. Cholesterol is having 27 carbons. Now, the nuclear structure of a steroid compound is characterized by a. So, nuclear structure of a steroid compound. Nuclear structure is characterized by naphthalene ring, no, not at all. It is having phenanthrene ring with a cyclopentane. Xylene ring, not at all. Cyclopentano, perhydrophenanthrene, all right. So, phenanthrene with perhydro, like each carbon of that particular phenanthrene ring is having more than one hydrogens, and there is also having a cyclopentano ring fused with that phenanthrene ring. So yes, this is the right answer for the structure about the steroid. So yes, C is the correct answer. C is the correct answer here. Okay, so steroids is having phenanthine ring fused with a cyclopentane ring. A fatty acid not synthesized in human body and has to be supplied in diet. Fatty acid that is not synthesized in human body and has to be supplied in diet, that is also known as the essential lipids or the essential fatty acid. Now it is stearic acid, oleic acid, palmitic acid or linolenic acid. So we have been asked about the non-essential. Okay, a fatty acid not synthesized in human body. Okay, so we have been asked about the essential acid, essential fatty acid. So what will be the right answer here? Okay, so yes, this linolenic acid, that is D, will be the right answer here. Like this linolenic acid is basically a essential fatty acid that has to be consumed from the diet. So yes, D will be the right answer here. Essential fatty acids are fatty acid that cannot be synthesized by the body and therefore should be supplied in the diet. They are also termed as the essential fatty acid chains. So essential fatty acids. Now, saturated fatty acids of arachidic acid contains dash carbon atom. So, arachidic acid is constitutes of 20 carbons. It will be formed of 20 carbons. 20 carbons. So, yes, C will be the right answer here. That is, it's the 20 carbon chain. So, yes, it will be the right answer. Like palmitoleic acid, so it's basically having 16 carbon, oleic is having 18 carbon. Like this linolenic or linoleic, both are having 18 carbons, while this arachidonic acid is having 20 carbon chains. Okay, so eicosanoids are also having 20 carbon chains, but they are unsaturated. Here also we are having arachidonic acid, it's also unsaturated one with 20 carbon chains. Which one of these is unsaturated fatty acid? Which is an unsaturated fatty acid? So palmitic acid, stearic acid, oleic acid or lauric acid. So this lauric is a saturated one, stearic is also saturated, palmitic is saturated, while this oleic 18 carbon chain is having an unsaturation. So oleic acid is basically made up of unsaturated carbon chain. So yes, oleic will be the right answer here. Like this is a unsaturated fatty acid chain having double bonds, Okay, so oleic acid is having one double bond, linoleic is having two double bonds, linolenic is having three double bonds, arachidonic is having four double bonds, while palmitoleic is having one double bond. Okay, so you simply just take a screenshot and try to learn them. In the next question we are having, which one of the following is referred to as good cholesterol? What type of compounds are referred to as good cholesterol? Is it triglycerides, high density lipoproteins, low density lipoproteins or chylomicrons? So it's none other than HDL, that is also known as high density lipoprotein. So yes, B will be the right answer, while this LDL or the low density lipoproteins are termed as bad cholesterols. Okay, so yes, bad and good cholesterol. So LDL is bad cholesterol while HDL is a good cholesterol. High phospholipid components are present in. Okay, high phospholipid components are present in. So high phospholipid components are present in LDL, HDL, VLDL or chylomicrons. When we talk about high phospholipid components, they are actually present inside the HDL. So yes, that's why it's also known as the good cholesterol. So yes, HDL will be the right answer here. HDL will be having the right answer. Lieberman-Bouchard reaction test is performed to detect. So when we talk about this Lieberman-Bouchard reaction, it's used for the detection of particular cholesterol, glycerol, fatty acid or ACE. So this Lieberman-Bouchard reaction is basically used for the detection of cholesterol. So yes, A will be the right answer here. Like in this Lieberman-Bouchard reaction, a chloroform solution of sterols is treated with acetic anhydride and sulfuric acid to give a green color. This reaction is basic calorimetry estimation of blood cholesterol. So basic calorimetry detection of blood cholesterol is done through this Lieberman-Bouchard reaction test. Grease spot test is used to identify. So grease spot test is used to identify protein, carbohydrate, lipid or alkaloid. So this grease spot test is basically performed for the lipids. They are performed for the detections of lipids. So yes, C will be the right answer here. Look, in a white paper, when we have a drop of water, it will look like something this. Okay, but when we have a drop of oil, then it looks like something this. So yes, this yellowness confirms that there are some presence of oil or fatty acid in that particular compound. Now, next question we are having, 𝙂𝙀𝘋𝐼 test is performed to detect. So 𝙂𝙀𝘋𝐼 test is performed to detect glycerol, cholesterol, fatty acids or vitamin D. So this 𝙂𝙀𝘋𝐼 test is performed to detect the cholesterol. They are also performed for the cholesterol detection. So yes, B is the right answer. So when we talk about 𝙂𝙀𝘋𝐼, Lieberman-Bouchard or Jack's test, they are all quantitative, or you can say that quantitative or identification test for the cholesterol. Quantitative and qualitative identifications of the cholesterol. Okay, next question we are having, which ketone body is detected by Gerard's test, like ferric chloride test, also known as ferric chloride test. So what kind of ketone body, which ketone body will be detected by this test, like acetone, beta hydroxybutyrate, acetoacetic acid, or all of these? So when we talk about Gerard's test or ferric chloride test, it is the test specifically designed for the detection of acetoacetic acids. Acetoacetic acids. So yes, C is the right answer here. Like this Gerard's test or ferric chloride test, it reacts only with acetoacetates. This is an indirect method to detect beta hydroxybutyrate in the urine. It's basically used for the detection of beta hydroxybutyrate in the urine. Nitroprusides has 10 times more sensitivity to acetoacetates than acetone. There is no reaction with beta hydroxybutyrate. There is no reaction with the beta hydroxybutyrate, but it will be reacting with the acetoacetates only. Which reagents are used in the Rothera test for detecting ketone bodies? So what is the reagent that you used during the Rothera test for detecting the ketone bodies? Is it a ferric chloride test and acetoacetic acid, sodium nitroprusside and NaOH, potassium iodide and hydrochloride, or bromothymol blue and sodium carbonate? So when we talk about this Rothera test is basically having the reagents of sodium nitroprussides and sodium hydroxide, or also known as caustic soda. So this sodium nitroprusside and caustic soda are the main reagents for the Rothera test for detecting the ketone body. So yes, C is the right answer here. Nitroprussides in alkaline medium react with the ketone group of ketone bodies, acetone and acetoacetate, to form a purple ring, and this confirms the presence of. This test is not given by beta hydroxybutyrate, and this confirms the presence of like ketone. If the ketone is present, then only a purple color ring will form during this test. Which ketone body is not detected by Rothera test? What kind of ketone body will be not detected by this, like acetone, beta hydroxybutyrate, acetoacetic acid, or all of these? So we have just discussed like this in Rothera test, there will be no reaction with the beta hydroxybutyrate. There is no reaction with the beta hydroxybutyrate. So yes, B is the right answer here, that this will be not going to react with the Rothera test. This is not going to react with the Rothera test. Which statement best describes fatty acids? So fatty acids are best describes that they are alcohol with hydrocarbon side chains. Okay, they are alcohols? No, not at all. They are esters with hydrocarbon side chains. All right, somehow correct. They are carboxylic acid with hydrocarbon side chain. They are amines with hydrocarbon side chains. So yes, basically they are having carboxylic acid with hydrocarbon side chains. So yes, this will be the right answer, the most appropriate answer among all the given options. So yes, C is the right answer here. C is the right answer. Like this fatty acid itself indicates that it's actually a acid derivative. So this fatty acid is a carboxylic acid with hydrocarbon chains and represented by a chemical formula of RCOH, where it stands for hydrocarbon chain. Now this hydrocarbon chain basically, or you can say that this acid basically reacts with the glycerols to form that particular triglycerides. Lipids are known to be soluble in which type of solvent? So lipids are soluble in what type of solvents, like water, organic solvents such as alcohol and ether, inorganic solvents, or none of the above. So the lipids are basically having long hydrocarbon chains which make them like hydrophobic. So they will be soluble inside water? No, not at all. They will be only soluble in organic solvents. They will be only solubilized in organic solvents. So yes, B is the right answer here. B is the right answer here. Lipids may be regarded as organic substances relative to insoluble in water due to long hydrophobic carbon chains. So yes, that's why they are soluble in only and only organic solvents like alcohol and ether. Next question we are having, what type of chemical compound are triaglycerols? So triaglycerol are what type of chemical compounds? Is they simple sugars, esters, amino acids or nucleotides? What we have been asked about the chemical compounds are triaglycerols. So triaglycerols are none other than the lipids. So yes, they are lipids. Is there any option given? No, not at all. So yes, the esters. They will be esters, since fatty acids are formed by the esterification of that particular like alcohol and acid. So yes, it will be esters. It will be esters. So yes, B will be the right answer here. So when glycerol actually reacts with the fatty acids, when fatty acids are reacted with glycerol, it will be formed triglycerides, and this is actually a ester. It's actually a esterification reaction. What are complex or compound lipid? What are complex or compound lipid? Is it simple sugar, esters of fatty acid with alcohol, proteins or nucleic acid? So complex or simple lipids are esters of fatty acids with alcohols. And what kind of alcohol they are? They are actually triglycerols. They are actually glycerols. So yes, B is the right answer here. B will be the correct answer for this. Like these are esters of fatty acid with alcohol containing additional groups such as phosphate, nitrogenous bases, carbohydrates or protein, etc. Next question we are having, which type of molecule is specifically hydrolyzed during saponification? So during saponification, what kind of compounds, what kind of molecules are specifically hydrolyzed? Are they proteins, carbohydrates, triglycerols or nucleic acid? So they are none other than triaglycerols. They are actually triaglycerols that gets hydrolyzed during that particular saponification reaction, and we are having glycerol and salt, that is soap formation, salt of that particular triglycerol. Which part of a fatty acid is hydrophilic? Hydrophilic, that means they are actually soluble inside water. They are water soluble. So is it a hydrocarbon chain? Not at all. The fatty acid chain will be having only two kind of components. Like one will be having acidic group and other will be having R group. And this R group is basically made up of hydrocarbon, and that's why this will be hydrophobic. And while this carboxylate, this carboxylic or carboxylate ion will be having solubility for that particular water. So yes, this like hydrocarbon, no, not at all. It will be hydrophobic, while this carboxyl group. So yes, this carboxyl group is basically hydrophilic in nature. This carboxyl group will be having hydrophilic nature. So yes, B will be the right answer here. B will be the right answer here. It will be hydrophilic, while this whole carbon chain will be hydrophobic. Next question we are having, what is the chemical formula of a cholesterol? So cholesterol is made up of 27 carbon chains, like steroid ring, like we are having phenanthrene ring fused with a cyclopentane group, and further we are having a 7 carbon that is having 5 carbon chain with 2 methyl substitutions. So yes, it is basically made up of 27 carbon chains. 27 carbon chain, no 30, no 25, no 20. They are made up of 27 carbon chain. Like we are having 1, 2, 3, 4, 5, 6 and one here with substitution. So yes, they are having 27 carbon chains. So these are the questions from the topic lipids. I hope you enjoyed the questions a lot, and I hope that you mark questions correctly, most of the questions. Alright, so thank you so much everyone for joining with us. We will be meeting you again with some new questions from some of the other topics of that particular biochemistry. Thank you so much.